Welcome to another lecture on topic 16, communication. Modern methods of communication rely heavily on waves. That's why communication is application of waves. This topic introduces the idea of different channels of communication together with modulation of waves and digital communication. Aspects of communication are studied through a comparison of advantages and disadvantages of different channels of communication. Reference, these are the various references you can look up, but in particular, you'll find this one will be very helpful. Cover quite a large area. Communication. Impact of modern communication. Having discovered how to produce and control electric current, successive generations of scientists and engineers have made the process of communicating over longer and longer distances, faster and faster, and more information being carried for lower and lower prices. That's the reason why you all can afford a smartphone. This has resulted in many dramatic changes to the ways in which people now expect to live their lives when compared with their ancestors of only a few generations ago. You can see the Chinese man buying a satellite dish, take home. Satellite news, world news, for example, is now broadcast by radio or television as and when it happens, direct. No need to wait for this. So that any listener or viewer can be kept up to date with current affairs. Right? Oh, you need a van with a microwave dish, and you can be near a war zone and monitor what's happening if the commander allow you to be there. World entertainment can similarly be broadcast, and this allows exposure of one culture to another, so that we are aware how people that they are different culture and be more tolerant. In the developed world, we use the telephone. The use of telephone has become so widespread that instant person-to-person communication is often taken for granted. We text our friend rather than spend time going out, chit-chat. Indeed, the ease with which communication can be established using the telephone has resulted in dramatic decline in the use of personal letter. So you hardly see in your generation personal letter. Right? At least during my generation, our means of communication will be letter, writing letter to friend from outstation, and it will take probably a week or two to receive it. Now it's instant. Further, the mobile phone has allowed instant communication from almost any locality, and this has provided not only business potential, but also a greater sense of security for its user. Right? You may be somewhere else and you may meet a businessman and you may chit chat, and then you find that, hey, there's a good business opportunity. And just phone your boss and say, and then explain to him, and instantly you can start a business. Right? They may give you a false sense, maybe, that of security, right? Where you are people chasing you, can go and hide somewhere and then phone for help. Right? It may give you a sense of security. Relatively recent popularization of internet has caused huge numbers of businesses to appear whose commercial operation provide employment to some and services to a great many. Right? Online shopping, you order your things. If more people order online, you need more people to service you. So the company need to employ more people. Okay, let us before we go further, let's just watch a video.
Long before telecommunications was a word, humanity was obsessed with the central concept, long distance. Some 40,000 years ago, the earliest methods of relaying messages consisted of smoke signals. Homer wrote about the early Greeks with fire, and drumming, very loud drumming. This was used in Africa. Although primitive, these approaches were invented at the time, relying on coded language. Certainly, there were other clever approaches. The Greek stereotype, the use of raven. But the real breakthrough in 1451, advent of mass communication. Johann Gutenberg, the German goldsmith, invented the printing press. He replaced months of scribe, duplicating documents painstakingly by hand. The technology concepts can be associated with a once many widespread access to knowledge, mobile. The history of telecommunications is a story of evolution, and often, as another progress was incremental. Invention was built on earlier ideas. In the 1790s, French engineer Claude Chappe, first telegraph system. With 136 miles between Lille and Paris, stone towers were constructed, far apart as 20 miles, and used to display flag-based messages. Electricity changed everything. 50 years after Chappe, Samuel Morse Hollywood created the telegraph. It relayed electrical impulses, Morse code that descended under the early smoke signals from wires. Soon, those wires extended across the country, even under the ocean. Then long distance communication was finally a reality. The telephone, invented in 1876, became a household device in 1940. It made telecommunication personal. Alexander Graham Bell's invention transmitted the voice. Early days, multiple people shared arguments. The journey to modern telecommunications punctuated not only with major milestones, but also with ideas that were ahead of their time. For instance, Bell's wireless telephone call in 1880. That breakthrough didn't catch on right away, but it eventually led to today's fiber optics. If the first 40,000 years were methodical climb, the last 30 years have been from the internet to smartphones to wearables, from email to texting to video chat. We all know this most recent chapter. What we may not have noticed, though, is how telecommunication has shifted yet again from communication between humans to communication with machines. We live in a world where internet-connected devices are constantly talking to each other. More often than not, they're talking about us.
Good.
Okay, let's carry on. Right? During the 60s, most houses don't have a telephone. So when my neighbor have a telephone, we used to go and borrow the phone because it's expensive to store one. And you cannot just phone freely as you do now. If you want to phone our station, you have to phone the operator first, and the operator, if there's a line, the operator will let it go through. If there's no line, the operator will say, wait. Half an hour later, we'll give you a line. So each person is probably given about 10 minutes to talk. After that, the operator will give you warning that your time is up. And it's very expensive. So normally, our station call, we have to somehow or other tell our relative that we will phone them which day so that they can expect and then stay at home, don't go out. Right? So now you can see that you use smartphone, you take for granted. Ours, only one person can use at a time. And then it evolved to the telephone, where many people can make a call. But now, you don't even have to look for a telephone post, make a phone call, just carry your smartphone around. Okay, let's carry on with channel communication. Just to review some of the things you may need to remember. Frequency is one of the period of the wave. Speed of wave is just the frequency times wavelength. And for sinusoidal wave, the displacement is amplitude sine omega t. Omega is the angular frequency, is equal to 2 pi f. Then intensity is k times. K is a constant, A is amplitude square, F is a frequency square. As far as your syllabus is concerned, you don't need to know about frequency square. But if you don't know about frequency square, then you find it hard to understand why intensity is proportional to frequency square. That means the greater the frequency, the greater will be the intensity. Right? But you don't need to know that. But it's no harm to know that. Your intensity, right, is spread out. So it means that further and further away, the intensity becomes smaller and smaller. Right? The energy that the person receives becomes smaller and smaller. So all you need to know is intensity is proportional to amplitude square. Intensity decreases with distance square. And then principle of superposition, where you add constructive interference, you got that. Right? Destructive interference, you get 0. But we are more interested in adding this type of form, different frequency, you got that. Right? Or you add the red waves, get the blue one. Now you are interested in having different frequency. Okay. Under communication, we will be looking at 16.1 communication channel. Right? Just a brief summary of different form of a medium that we can use to send our signal or information. Coaxial cable, wire pair, radio, microwave link, and optic fiber. And under modulation, we look at frequency amplitude modulation, carrier wave, and sideband, and bandwidth, and AM and FM transmission. Then we go to 16.3 digital communication, advantages and disadvantages, and ADC and DAC. Right? ADC is analog to digital conversion. Then we go back to here again. Right? The different channels of communication. We look at the merits of different channels of communication. Which one to use? Right? You will encounter noise and bandwidth and crosslink, where we will encounter it here. Then satellite communication, and we will look at attenuation, where the amplitude decrease with distance. We will use a log scale. And mobile phone, the use of microwave, that one is normal in the syllabus. Right? Or we can summarize it by pictorial form. Coaxial cable, optic fiber, wire pair, right? Satellite communication. Right? We can have radio transmission and modulation. There's a amplitude modulation, there's a frequency modulation, and radio spectrum, and your analog digital signal. This analog, this digital. And we look at the merits of all these different forms of communication. Okay. We'll be also looking at how waves travel. And attenuation, amplitude decreases, so we have to amplify it. And of course, we will encounter noise. Communication channels. Right? Telecommunication, we have information, sound waves. Right? We produce from the sound wave, we produce an image. We always call that image, but basically this is alternating current of the sound wave. Same, the variation of sound wave converted to alternating current. Then we have to have a carrier. Right? This is our information as alternating current. We add to a carrier, and then we send it out by an antenna as electromagnetic radiation, received by an antenna, and then we have to separate to get the information back, the signal back. Remove the carrier, and then the loudspeaker will produce a sound. That's just a summary. So telecommunication system, example, radio and television, telephone, send information from one place to another using electric current or electromagnetic radiation. Right? So this part, electric current in the air will be your electromagnetic radiation. The information being sent may be sound, picture, or computer data. Signal for sound, example, speech are called audio. Anything made of sound, audio, we can hear. Right? We call it information, or we call it signal. Right? That's our speech, our data. For high quality transmission of music, audio frequency from 15 Hz to 50 kHz may have to be transmitted. So if you want to reproduce your sound faithfully, my voice faithfully to you, then I must transmit from 15 Hz to 15 kHz. Speech only need frequency up to 3.4 kHz for people to understand. So you don't need up to 15. You don't want very clear sound that you can understand, good enough. For reasonable quality music and good quality speech, the bass bandwidth range has to be 50 Hz to 4500 Hz. Keep in mind that, and you will understand why we choose a bandwidth of 9, double that. Bandwidth of 9 kilohertz. Right? Double that. This range is used when transmitting signal by medium and long waveband radio. Information. Video information. To transmit black and white video, TV information with sound, a much wider bandwidth is required of about 8 megahertz. For color TV, channel is needed for each of the 3 color, blue, red, and green. Right? Each channel is required for different color, and then we mix that up to get a different color on television screen. So you can see the bandwidth, or we'll define bandwidth later on. For color TV is greater than black and white. And to send audio is easier, shorter bandwidth than TV. Right? So we can think of different channels of communication as different pathway to our destination, which path to take. If we want to consider cost, convenience, safety, fast, and noise. So same thing, we will consider the different channels of communication under similar heading. Communication system. Simple, person to person. Yeah, person A, person B. Channel can be your sound wave, or it can be your medium, the atmosphere. Right? You allow your sound wave to pass through. A channel is an information pathway within a transmission medium. Right? So the atmosphere allow your sound wave to pass through. By means of multiplexing, many channels can be accommodated within one single medium. The medium can be a wire pair, can be coaxial cable, can be optic fiber, or atmosphere. So in this case, one person only. If I speak to you, you speak to me. Only one person can speak at a time. So in a sense, it's limited. But when we multiplex, like sending radio station, we have radio station that using radio wave, we have different carrier frequency. So many stations can have, not only these two, can have many stations in a locality using different carrier frequency. Right? So summarize for you, your channel is the information pathway within a medium. Right? Can be atmosphere, can be space. And then we can use radio, a microwave link, right? Different carrier frequency, there's different channel. And the medium can also be optic fiber, coaxial cable, wire pair. Right? This is a wire pair, two wires, right? Like black and white, coaxial cable, right? And the wire is actually is two wire, except that there is the internal wire, right? And then the external one is surrounding it. We will study more in detail later on. Optic fiber, right? There's optic fiber, thinner than your coaxial cable, cheaper also. Right? There's your wire pair, carry on top of a pole. There's your coaxial cable, that's how it looks like. This is your return wire. Right? We use black and white, black and red. So here there's the earth one, there's a signal, there's a center one where they send the signal. And then there's optic fiber. Or you can have a satellite. There's your microwave dish. Then the satellite receive by microwave is further away. You can have radio link, radio transmission, and you can have microwave link from here, one place to another on the ground. But we'll look at an example of this one to show what is involved in communication. Multiplexing, right? We'll come across that. You can think of either all these are different people or different radio station. Right? Previously, where we have one person speaking to another person using sound wave, only one person can speak. The other person must listen. If too many people try to speak, then we have interference. But now, no problem. We can have the same atmosphere. We can have different station in a particular locality. It's called multiplexing. It's a process of allowing several independent users to share the same transmission medium or link. Right? So in radio communication, we use different carrier frequency, allow different radio station to share the same airspace. Or we call it frequency multiplexing. Use different carrier frequency so that different station can use that frequency. Right? We'll go into more detail in the next topic. Right? Medium, the atmosphere, you can use different carrier frequency for different radio station. Or in same locality, and you may want to see some of this power line there and telephone line there. Modulation, right? We will take a start. Communication by sound wave. Amplitude modulation. Right? We want to look at first modulation. What is modulation? Is the variation in either amplitude or frequency of a wave. Either there's your amplitude, there's your carrier with the high frequency and the signal or information, and you combine it together using principle of superposition, you get your modulated signal. Or you can have a frequency modulation, right, where the frequency is the one change, amplitude remains constant. That's why it's called for frequency modulation. So either change the amplitude of the carrier or you change the frequency of the carrier. Either in synchrony with the displacement, this one, right? This one, the displacement of the carrier varies in synchrony with the displacement of the signal. Or in this case, it's the frequency vary in synchrony with the displacement of the signal. Right? That's how we carry information these two ways. Amplitude modulation or frequency modulation. Telecommunication means sending information from one place to another. The communication system with which we are most familiar is that of person to person. Consider what is required to make this system work successfully. You got two persons, A and B. As A, the source of information, the person's brain, A's brain and voice. Receiver of information, B's ear and brain. Carrier of information will be your sound wave. Medium will be your atmosphere. Channel your atmosphere or your sound wave. Constant sound by A, send you nothing, cannot communicate anything at all, cannot communicate his thoughts by his voice. A sound or no sound, stop, then it can carry information. We can have different length of sound like the Morse code. As long as A and B agree on the code, then it is possible to transmit information as series of simple grunt, sound, no sound, different length of time. What does it mean? Weakness, right? One person can speak at a time. Too many people speaking, we have interference, cannot understand each other anymore. So we must have a quiet place where we can communicate the information. Radio communication, right? That's your electromagnetic spectrum, right? That we have studied in your AS physics. Gamma ray, you can remember the size of nucleus. X-ray, the size of atom. This is in terms of wavelength. This is roughly the magnitude of different wavelength. Infrared is in the region of the cell. And a microwave, you can think of a period or a full stop, a dot. And then radio wave, you can think of a 10-cent coin. 6 cm. In terms of frequency, we can see that 10 to the power 19, 10 to the power 16, 10 to the power 14 there. And then radio microwave is about 10 to the power 9 there, or 1 gigahertz. So basically, we are interested in this region, microwave and radio wave in communication. Right? Remember, lower frequency means longer wavelength. Okay, so you can see that microwave 0.6 millimeter, And then that is in terms of frequency, that's in terms of wavelength. So low frequency correspond to high wavelength. So this is just to give you a rough idea. If you have 30 kilometer, then the frequency is 10 kilohertz for electromagnetic waves. Okay, so we are more interested for radio communication, 30 kilohertz to 300 gigahertz. Audio range, right? Sound is 20 hertz to 20 kilohertz. Right? Yes, this end there. Right? Different from the spectrum, but just to give you a rough idea, that is the frequency we are involved, and that's a high frequency that we use for radio wave. And if we use the speed of sound, then we can see that the wavelength for sound is about 1.5 cm to about 15 meter, depending on the frequency that we use. Frequency band, right? You need to know roughly the band there. We got the microwave, 1 millimeter, 10 cm, or 300 gigahertz to 3 gigahertz. AM means amplitude modulation from 30 to 30 megahertz. Frequency modulation is from 30 to 300 megahertz. And LW is your long wave. MW is your medium wave. SW is your short wave. Right? So your TV is from 0.3 gigahertz to 3 gigahertz. Times 10. Right? Each of these times 10. FM is from 30 megahertz to 300 megahertz. Then you have your AM, right? Where your short wave, medium wave, and long wave are under amplitude modulation. So it's from 30 kilohertz to 30 megahertz. 30 kilohertz, 30 megahertz. Radio transmission. Right? You have microphone, you have sound wave going to the microphone. So the sound, right? We usually call the image, but it's actually the image is in the form of alternating current of the sound. That's how we get alternating current of the sound. And then since it's soft, you have to amplify. So we have amplifier, make the amplitude larger. Make the amplitude larger. Then we need a modulator where we add a carrier. Right? If we send directly sound wave using area, we are using very low frequency. And then we need a large area. So in order for using a smaller area, we use a radio wave as our carrier. So this is our carrier. That is our information. We use a moderator to combine the two together. Right? So moderator add the alternating current to the sound wave there, to the radio wave. And that's why we get amplitude modulation. And we send it to the area, transmission by the area, then the radio waves. Okay? So that's a brief summary of what we do for radio transmission. And you look around, you see all these in different places there, right? Different area or antenna or area, right? Can be of different form. Right? We can think of area, a transducer that transmit, it also receive electromagnetic waves. It convert electromagnetic radiation into electric current or electric current to electromagnetic waves. Right? These are your different forms. That's for your radio. Right? And you can see that now the small, now it becomes smaller and smaller that we can't even see them. Antenna generally deal in the transmission and reception of radio waves and are necessary part of all radio equipment. Physically, an antenna is an arrangement of one or more conductor. Basically, a conductor, that's all. What can be arrangement of one or more conductors, usually called element in this context. So you have an area antenna, and then you have your AC source. Right? That AC source represents your alternating current coming to the antenna. So in transmission and alternating current, will move up and down this wire and create in the antenna by as if there's an alternating voltage going up and down. Right? Or another way of thinking of it is there is an electric field, changing electric field going up and down. So that changing electric field will produce a changing electric field in the atmosphere. And that changing electric field like a current, right? Your right-hand grid rule, where you have a current, you have your magnetic field around it. So if the current is changing, the magnetic field around it is also changing. So that is why we have the magnetic field, electric field changing. At the same time, the magnetic field is also changing because the current is changing. So as it changes, the electromagnetic wave is sent out, right? Or radiate out electromagnetic field as electromagnetic waves. Okay. So basically, alternating current in the area produce changing electric field. And the changing electric field will produce a changing magnetic field. Right? Remember, it's a current that changes that produces an electric field, and it's a current that changes that produces a changing magnetic field. So the electric field and magnetic field are in phase. And because it's only in one direction, quite polarized radio wave radiate outwards. Right? Same like what we have learned in our electromagnetic induction, alternating current source. There's your coil. Right? Changing current here will produce changing electric field here. Changing electric field here will induce changing electric current or EMF across a coil, and that's how we get our induced EMF in the secondary. Right? So in reception, the reverse occurs. The electromagnetic radiation comes to the antenna. The electromagnetic field from another source induces an alternating current in the antenna. Right? So if there's an alternating current, you can think of it as a changing voltage on the antenna's terminal. Optimal size for antenna bears a strong relationship to the frequency of the signal it is designed to receive. Remember that the higher the frequency of the signal, the smaller the wavelength. Ideally, an antenna would be the same size as the wavelength. So that's why we cannot use sound to communicate. Cannot use sound wave, then change it to radio wave, and then send our information, because we need a very, very large area. And because the frequency is very small, right, intensity also very low. So ideally, an antenna would be the same size as the wavelength is designed to receive. This means that high frequency signal requires smaller area, and low frequency signal requires large antenna. That's why cell phone, for example, can use small area. Their frequency is relatively high. Your smartphone, we use microwave. That's why you hardly see the antenna. So tiny. AM band frequency is about that. Right? Depend on the country. Correspond to wavelength about 200 meter to 300 meter. This long wavelength dictate long antenna. I can see this style of transmitting tower antenna on hilltop. Then you know it's AM transmission. So you have a receiver and then you have a transmitter. Basically, you have a transmitter here and then you have a receiver. Basically, the receiver is the same thing. You receive, there's a receiving antenna. You tune it because there's so many radio waves coming from radio station. Tune it means you select the particular radio wave you want. You remove the radio wave, remaining the signal. That's why it's called demodulator. And because it's soft, you have to amplify it before it goes to the loudspeaker. So we can summarize your information source, your speech, your signal. You have to encode it first. It means you have to combine the information or your alternating current with your radio frequency. Encode it. Then we transmit it. Then on the receiving end, the receiver, we have a decoding device, demodulator. Remove the radio wave, and then we receive back our information. So basic telecommunication system, we have information source, the radio station that produce the broadcast, music, the news, and then encoding device, and we send it either in air or by different medium like cable, optic fiber, and decoding device. And finally, we get the information back. Okay, so that's the end of our lecture. So if you want more information, you can either go to Facebook to download my notes and PowerPoint and video, and you want to practice past paper and download it from also my Facebook under Physics A2. You need to try out the question so that you're familiar with how CIE will ask the question. If you don't have a Facebook account, you can go to YouTube, you can Google my name, and then you can look for communication channel. Thank you. See you next time. You can ask questions on the YouTube or Facebook. I'll answer you.